In this video, I'm going to go over evaluating rational exponents. What is a rational exponent? Well, rational number is any number that can be expressed as a fraction, right? So the decimal of the number can go on forever, but there's a certain pattern to it. It's a repeating pattern. But if the decimal doesn't repeat and it goes on forever, then it's irrational. So all we're talking about is rational exponents. And if it can be expressed as a fraction, then basically it's just an exponent that is a fraction. That's all we're talking about here. So what if we had 8 to the power of 2/3? 8 over 2/3. Well, would it be crazy for me to tell you that we've actually been dealing with a particular rational exponent this whole time? It's called the square root. Square root of anything is the same as that thing raised to the power of 1/2. And when I say anything, I should probably use a variable instead. Square root of whatever number is the same as that number raised to the 1/2 power. So what does it mean if your denominator is 3 instead of 2? Well, then that would be simply the cube root rather than the square root. Make sense? All right. So when we evaluate these, we like to split them up into whichever one is easier. And order actually doesn't matter. You could do the squared first, or you could do the cube root first. In this case, let's do the cube root first, and then square it. And yes, you can write it like this, if that helps you. And it certainly helps me. Cube root of 8. Okay, what number multiplies by itself 3 times to get 8? Well, it's 2, right? 2 times 2 times 2. So 2 times 2 is 4. Bring that 2 down. 4 times 2 is 8. So the answer would be 2. That's the cube root of 8. But we're still squaring it, right? We're not done yet. That we just took care of the denominator with that part. That one was 2 squared is 4. And that's your answer. All right, let's do a few more examples. A couple of them will have negative exponents, but don't worry about that. Because when you have a negative exponent, all you're doing is taking the reciprocal of what you have and you get a positive exponent, right? So 9 to the negative 3/2 is the same as 1 over 9 to the 3/2, positive 3/2. Same thing. All right. So now, then 9 to the 3/2, that's the same as square root of 9 cubed, right? Square root of 9 is 3. 3 times 3 is 9, right? Yeah. 3 cubed. All right, so now we got to multiply by itself 3 times. 3 times 3 is 9 times another 3 is 27. But I forgot something. 1 over. It's 1 over 27. Oof. Got myself there. So that negative makes it the reciprocal of what 9 to the 3/2 would be. We can do that same thing over here. You just pretend the negative isn't even there. 64 to the 1/3. 1/3 is cube root of 64. What multiplies by itself 3 times to get 64? 3 times to get... I think it's 4, right? 4 times 4 times 4. 4 times 4 is 16 times 4. What is 16 times 4? 6 times 4 is 24. 4, 5, 6. Yep. Okay, so it would be 4, but it's negative, so the answer would be 1/4. Think of it that way, if that helps you. Always remember, when you have a negative exponent, you take the reciprocal of this number, not the reciprocal of the exponent, reciprocal of this number, and the exponent becomes positive. Same as 1 over 64 to the 1/3. All right, last one. 32 to the 4/5. Well, we're not going to multiply 32 times itself 4 times just to find out what the fifth root of that huge number is. So let's take the fifth root first. And this time, no reciprocal because it's positive exponent. And don't forget to raise it to the power of 4 when we're done. Now, fifth root of 32. Oh. Well, let's start with smallest possible number. 1, 2, 3, 4, 5. Okay, so 5 2s give you 16 times 2. That is 32, isn't it? So yeah, 2 is the fifth root of 32. Okay, so 2 is our answer. But we still need to raise it to the power of 4, right? 4/5. So 2 to the 4th would be 16. We just did it. There you go.